Record on this computer. Going to record on this computer now. Let's talk about the very first behavioral economic model, and that is inequity aversion. That's going to be the name of the model. So in the first week or two of the class, I introduced the class by saying, here's what behavioral economics is. It's incorporating psychological realism into economic models to improve on their own terms. Well, how do you do that? I think today will be the first example of a model that does try to do that. It says there's a model of how people make decisions that we can improve by creating a new model that includes, they're called social preferences. And it doesn't mean like what kind of society do I prefer, or how extroverted or introverted do I prefer to be. That's not what it is. It means how would I prefer the distribution of something to occur in a society, in a group. And that's what it means. I have preferences over how fair I want things to be, how one-sided, how, okay, so that's what I would like today to be about. And there's a video you can watch me from 2 or 3 years ago, explaining this model of, it's called, let me write it in the, I gotta everyone in the meeting. Here's what the name of the model is called. Inequity aversion. And it's by 2 economists. They're both Europeans. I think they're Germans, or perhaps, what is Ernst Fair? Ernst is a German name, I think they're both Germans. Ernst Fair and Klaus Schmidt. Yeah, actually, you don't get more German names than that, as far as I think. But this model of inequity aversion is what one of 2 models I'm going to ask you to learn for this class. The whole class, it's like 15 weeks of behavioral economics. I could have given you like 15 behavioral models that you had to learn and learn how to use. I think that would have just been overwhelming. So I narrowed it down to 2. The 2 behavioral models I will have you learn and hopefully be able to use are the model of inequity aversion by Fair and Schmidt, and the second one is called the cognitive hierarchy model, and that's by my favorite behavioral economist, Colin Cameron. And we'll learn that later. First one, let's do this one now. Let me share a slides with you. You can see. So once I share slides, I guess it doesn't matter if you have your cameras on, because all we're going to see is the slides. Sorry, I have to press enable editing. There we go. Slideshow from current slide. So here's my introduction slide. Social preferences, featuring the model of inequity aversion by Fair and Schmidt. Okay. This is a table that I have put up many times before, and it's just a way to summarize all of these differences between Homo economicus versus Homo socialis. Hopefully by now you're comfortable with this terminology. The first term, Homo economicus, that's rational, self-interested man, like the perfect model of an economic agent, called Homo economicus. Homo socialis is a different model of a person, the one who generally is thinking about what's the best thing to do for society, not just for me, but in a pro-social way. What should I do? How would I like everyone to behave? It's kind of like the golden rule: treat others as you would like to be treated. That's what it means to be pro-social. It doesn't mean give away all your money and make yourself suffer your entire life just so that other people can have something better than you. That would be sort of the ultimate kind of sacrificial, altruistic person. That's not what a pro-social person is. We'll talk about that later. But then I have these 4 categories. I have these 2 examples in each category. We talked a lot about the ultimatum game and the dictator game. Those are about how people choose to bargain. How much they care about fairness in bargaining. The cooperative behavior, prisoner's dilemma, is the easiest example of cooperation, but so is a public good game. A public good game is about, as a group of people, how much are we willing to contribute to something that will benefit us all? That's a public good game. These are cases where homo economicus and homo socialis different. The reciprocal behavior, I gave you these two examples. The gift exchange and the trust game are two very good examples where people respond to niceness. If you're nice to me, I'll be nice to you. And then the final thing here, the deception game. We talked about that in class, the deception game. I didn't talk about these cheating experiments. But generally, let me just give you one example of a cheating experiment. You sit people in a room, and they're in their own little cubicle, so no one else can see what anybody else is doing. And you give them 2 dice. You say, all right, roll dice. And your goal is to roll boxcars. You try to get a 12. Try to get 2 6s on your dice. And if you get it on your first try, you get like $20. You get it on your second try, you get $19.50. You get it on your third try, you get $19. Fourth try, $18.50. So every time you roll your die, you lose 50 cents. Let's say that you're in this game, and so that's 20. If 20 rolls go by and you still haven't gotten it, then you just get $10 and you leave. So the question is, can you roll boxcars in the first 20 rolls? So, and you'll get paid somewhere between $20 and $10. And no one's watching you. No one can tell how many times you roll. No, let me say that again. No one can tell whether or not you actually rolled the 12. It's totally up to you to report if you rolled a 12, and if so, on what roll. What would you guys do in this situation? No one can tell. You can say you rolled 12 on your first roll, walk out of there and get 20 bucks. Or you can keep rolling and say, well, I never got it. I never got a 12. I'll take I forget what the low payoff was. Maybe it was 5. Maybe it went all the way down to $5. You still got something. You didn't walk away with nothing if you never rolled a 12, but you got a lot less. What would you do? Would you be honest and do the rolling and see when you got the 12 and then mark it and then go get your money? Or would you cheat the system and and say you got a 12 when you really didn't? What would you do? Peter, you just unmuted yourself. Do you want to say something?
I was going to say, I'd like to think I'd be honest, but I think that specific experiment sounds like it has a lot of, I would be really suspicious that I'm being watched somehow. So just the construction of the experiment makes me think I'd be more honest than usual.
So, great point. What you're saying is there's perceived scrutiny in your behavior, which activates your sort of moral obligation to not cheat. So in this experiment, they did everything they could to prove to the subjects that no one's watching them. No one will ever see if you rolled a 12 or not. Let's say they took the precautions. There's definitely no cameras. Your cubicle has the privacy that you can guarantee that you're doing it, no one can see, right? Let's assume that. Then what would you do?
I'd like to think I'd be honest, but I think that hypothetical doesn't exist in the real world.
That's true. That's true. This is totally an artifact, an environment created specifically to test cheating. In a monetary situation, so there are monetary stakes. You could either win $20, or if you never roll a 6, you lose. Let's say you go all the way down to 5. I don't remember exactly what it was, but so there's like $15 here on the table. If you cheat, say you got a 12, you get the full amount of money. Or you could cheat in sort of a middle way and say, actually, I got the 12 after rolling 6 times. The real probability of rolling a 12 is 1 in 36, right? Mm-hmm. So on average, people are not going to roll a 12 ever. I mean, they might get lucky. And that's part of the experiment, is to see when you have this, you have this plausible deniability. Nobody can look at your score, your sheet of paper that you filled out and say, oh, you definitely cheated. no one will ever be able to prove you cheated because it's possible you rolled a 12 on your very first roll. The clever thing about this experiment is that they got zero data about who actually cheated as an individual. But what they did have is aggregate data, right? You can aggregate everybody's data and say, here's how many people said they got it on the first roll, the second, the third, the fourth. And what do you think? Does the data look, well, the first thing to notice is not everybody says they got it on their first roll. People are not all cheating and saying, I did it on the first time. However, people are also not telling the truth. And the way they can tell they're not telling the truth is when you look at the rolls on average, in aggregate, they don't look like the probability distribution that you would expect to see. So people are cheating, but they're cheating just a little bit. Isn't that weird? They don't just go all out and say, yeah, I got it on the first time. Somehow that feels wrong to them. I will say that some people do say, some people, of course, were like, all right, I did it on the first roll. But most people don't say they got it on the first roll. They have some like little bit of cheating. They want to think of themselves as a person who generally tells the truth, but they're willing to cheat a little bit. So Dan Ariely and his co-authors, they do all sorts of weird experiments like this to just really probe out how much people are willing to do for money. And the reason I brought it up is that this, again, is one more difference between, you could be seen as a difference between somebody who thinks I always have to do the right thing versus someone who thinks I just want as much money for myself as I can possibly get. Yeah, I'm not sure how good of a segue this is to the pro-social preferences. Because what if you're just taking money away from the experimenter? That doesn't seem so bad, does it? Like, let's say you cheat. You say you didn't roll a 12, but you pretend like you rolled a 12, and you're getting more money than you deserve, quote unquote, from the experimenter. Is that really so bad? Can we justify that?
Sure. You're gonna take a nice stroll over to Prospect Park in cool Brooklyn. Mix some shirt on. You know,
I don't think
eat a
this guy
fucking
knows.
Popeye or Funyuns or whatever snack you don't even like.
What else is cool nowadays, Adam?
Yeah. Playing Fortnite because you heard black kids playing.
Yep, that's true. It is fun. I just suck at it.
It was James. I muted James. All right. Daniel says you would lie. Is it because you're not hurting anybody by saying you would lie? Daniel?
Yeah, I think it would be a pretty clean getaway. I think there's no reason not to, honestly.
Because when you say getaway, well, literally it means you're getting away with it. No one can tell you did it.
Yeah.
But
Yeah.
in who is hurting? Well, let me say a little bit about how these experiments are run. I'm one of the people who runs experiments, and I get funded either by VCU, they have a fund of money that they're giving me, or from an outside organization like the National Science Foundation. I have an NSF grant now, actually. I was very lucky to get this NSF grant. But there is like a pot of money that I have to use to do research. So what happens if let's say you cheat me as the researcher, you're really only supposed to get $5 in this experiment, but you take 20. Is it my money that you're stealing? No, I don't do the experiment with my own money. But I do use a limited, capped amount of research money that I have to do research with. And if you take a little bit more of it than you deserve, that means there's less research money that I could use for other purposes, to do other experiments. So in some sense, you're still, yeah, you know, who are you stealing from? Is this Robin Hood? You're stealing from the rich to give to the poor? Yes and no, in a certain way. Interestingly, these honesty experiments have also checked what's the difference when the person you're taking from changes, like whether you're hurting another person or the experimenter. And long story short, of course, it does matter. Like if you people are more willing to tell a white lie than a black lie. In other words, a white lie, I don't know why they're called this. Sounds kind of racist now that I say it out loud. But in the parlance of this literature, it's called a white lie if you can tell somebody something and if they believe it, it actually helps them. For example, like if you're married and your your wife says, "Does this dress make me, look fat?" You say no. I mean, that doesn't apply to me. That's the stereotype. Forget I even said that. A better example of a white lie would be maybe something kind of paternalistic, where I tell you this is true. I tell you this is true, and it actually helps you to believe it. I don't know if COVID is an example. Like if I told you that this is weird, but if I told you somehow that COVID is very dangerous and will get you infected if you do this certain thing, and I'm telling you this so that you won't do the thing that'll actually help you in the long run. That's a bad example too, because I don't want you to lose faith in scientists who are telling you things. Anyways, they're called white lies if you are saying something that shouldn't actually hurt the person. At least it won't hurt their payoff, their dollars amount. Are people more willing to tell white lies than black lies? Absolutely, they are. And I did an experiment that's kind of like that, and so did Yuri Gnesi, and we both found the same thing, really, which is that there is a correlation between who you're harming and how honest you're allowed to be. The more harmful you are to people, the more this kicks in where you want to be more pro-social. You want to do the right thing and tell the truth. So in the cheating experiment, rolling 12, I do think it matters that you're just taking money away from the experimenter, and people can really justify that and say and think to themselves, well, what else am I supposed to do in this experiment? They're offering me a free $20. I should just take it. I'd be stupid not to. That sort of thing. Okay, I wanted to talk about that because that was I felt like the last segment of this chart that we hadn't talked about. So now we've talked about the whole chart, I think. Okay, let's look for some commonalities. What do these differences between Homo socialis and Homo economicus, what do they have in common? Summarizing again, it's about cooperation, reciprocity, trust, honesty, fairness. They all seem to be about caring about other people's payoffs. And payoffs may sound like a jargony term, but really here it just means like the outcome of the other person. How well off am I leaving the other person? And they all seem to have this in common. Maybe you agree, maybe you don't agree, but that's what I think. The studies of cooperation, like Prisoner's Dilemma, if you find that people cooperate in the Prisoner's Dilemma, you can kind of think of it as, I don't just care about myself, I care about you and your payoff too. I want us both to do well. That seems to be the main difference. I'm arguing now, and you can tell me if you agree or not. The main difference between Homo socialis and Homo economicus, and at least in those games that I showed you on that table, is how much you care about other people's payoffs. What does Homo socialis really want to happen that Homo economicus doesn't care about? What do they want? You have an answer to this? I sort of answered it already. I'm gonna go to the answer. What do they want? What's their goal? What is Homo socialis looking to make happen? If they could choose any outcome, what would they choose?
To maximize everybody's payoff?
Pretty good answer. Maximize everyone's payoff. Here's what I wrote. They want prosperity, which is shared fairly among pro-social members of the group. Right? So if somebody's really acting like a jerk, they don't want that person to benefit. But for everyone who is also pro-social, like they are, they want those people to all prosper, to maximize payoff. It's a good answer. So we need a model that captures that. If we're going to try to explain pro-social behavior with a model, that means a math model. We're using numbers now. We're not going to just talk about how you think and how you feel. We're going to use numbers. We need a model that captures that with numbers. Okay. It's called a rational choice model. That's what that's called. Why can't I go to the next slide? Here we go. We want a rational choice theory of social preferences. Remember, social preferences are just a way to describe what I would like to happen, not just to myself, but to everyone in society. That's what we call social preferences. Why do we want this? Because science. This is my attempt to sound like the youth of today. This is a parlance that didn't exist when I was your age, to use because as a preposition. Because science. All right. That means this is what science does. It creates a model, it creates a theory about the world, try to explain the world somehow, and then it tests that theory. If the theory has a lot of evidence which supports it, it becomes generally accepted. If not, then we reject it. But this is the whole process of science. This is what behavioral economists want to do. Here, let me be a little more specific. The third bullet point, what it means. We should write down a theory. Usually that means a utility function. I wonder why it's not an utility function, it's a utility. Usually when you spell that out, it looks weird to have a instead of an, but when you say it, it sounds fine. A utility function. That predicts what an individual will choose. How does that do it? Well, usually because it's maximizing the utility. The point of this slide is to explain to you what a rational choice theory is, so that afterwards we can give you a rational choice theory or a rational choice model. Either of those count. What do we want the rational choice model to be? It should be testable. The theory should be testable so that we can look and see, well, do people actually maximize their utility according to the model? If the model says they'll do this thing that maximizes their utility, do they actually do it? What else? The thing that you want to study, in this case, it's a distribution of payoffs. Not just my payoff, but everyone's payoff. All of that should be included in the utility function. Am I skipping ahead here? Do you guys know what a utility function is? I think you do. Utility function, for those of you who may have forgotten, it's something which takes one or more multiple arguments as an input to this utility function, and the output is a single number, one real number that we can put on the real line. And the point of doing this, of taking, the inputs to a utility function could be arbitrary. It could be anything. It could be, how many bowls of Cheerios I had this week. It could be how many times I've been to the gym, or how many free throws I made shooting baskets this morning. Whatever the inputs to the utility function is, those are sort of arbitrary. But the point is it spits out a single number. And that single number is very important, because if something gives you a higher utility, it means you prefer it. So if whatever, making 8 baskets and eating 2 bowls of Cheerios gives me a utility of 5, and making 6 baskets but 3 bowls of Cheerios only gives me utility of 4, the point of the utility function is to say, I will prefer the thing that gives me a higher utility. Okay, most of you, I'm sure, already knew what a utility function was and what it's used for. But in case you didn't, that's my preview, my review. Okay, so in this rational choice theory, the thing that we care about, the thing that we're studying, is the distribution of payoffs. Not just my payoff, but your payoff, his payoff, his payoff. All of that stuff should be included in the utility function as an input, not as an output. The output still has to be one number, one single number, but the input could be multiple things. Okay, third bullet point. Behavioral parameters should be introduced in order to explain heterogeneous behavior. You guys know what this means? Heterogeneous behavior just means different behavior, different people behaving differently. Remember the Kevin to Brody spectrum? That is the heterogeneity. that we're going to talk about here. In other words, like everyone has a number, has a type, and the type exists somewhere on a spectrum. And on one side of the spectrum is Brody, and the other side of the spectrum is Kevin. And this parameter explains the differences that we see in people. Some people that behave like Kevin, it's because their parameter was all the way in the Kevin end of the spectrum. Some people behave like Brody, it's because their parameter was in the Brody end. Some people are in the middle. That's fine too. That's what a spectrum does. That's what a parameter does. Okay, so this is my description of what I think a rational choice theory is. We're gonna talk about one. You have plenty of time, right? Ooh, it's 1:03. We're talking about one about social preferences now. Here's an introductory example. If you've watched my video, you've seen me do this one already, but I'm curious what you think. Let's say there's a psych experiment. You get paid $10. You know, everyone comes in, everyone does the same thing in the experiment, and you get paid $10, but everyone else gets paid 20. You can see everyone else getting paid 20, everyone else gets paid 20, but you only get paid 10. Would this annoy you? And if so, why? Anybody willing to explain? Would you care? Maybe you don't care. Or would you care? Would it be like, what the heck? Why do they all get 20 and I get 10? Would it like sort of ruin anyone's day just to know that that happened?
I don't think it'd ruin my day, but yeah, seems unfair.
Seems unfair. It would annoy you. Anybody else? Oh, they're gonna go in the chat. Emily says it's bother you. Jay says it's unfair. Yeah, so it seems like it would bother you because it's unfair. Why did they get 20, Jay? It was totally arbitrary. They didn't do anything special. It was just, you know, in my video, I call it a medical experiment, and I sort of like that idea better. Like they're just going to use some of your DNA for something, and it has nothing to do with who you are as a person. And some people get paid more than you. And okay, good. I think this is the most common answer, is that yes, it would annoy you, and because it's unfair, it's unpleasant. What if you could change the payoff so that everyone would get the same amount? Everyone gets $8. There's no more inequality. Everyone gets 8. Would you change to this, and why? I'm curious if you would give me more answers. I love answers. I love feedback. Would you guys change it so that everyone just gets $8 instead?
I would not.
Would I know about the first offer? Yeah. Who said we would not? Fergus?
Yeah.
Grant said no. Jade says no. Nah. Brody says no. Alexandria says no. Emily. Okay, so I didn't choose the numbers very accurately. Everyone would rather have. If I knew about the first offer, I wouldn't change. You would actually want to keep it so that you got 10, even if everyone else got 20.
Well, it'd feel like you're punishing the other people instead of just making things fair.
You wouldn't want to hurt other people?
Yeah, I guess. If it was instead make it $19 for everyone, then yeah, okay, maybe.
Oh, right. But that helps you. That a self-interested
Right.
person would definitely want to do that also.
Certainly. But I mean,
Yes.
I don't want to take $12 away from everyone just because I'm getting shafted.
Yeah. Okay. Wow, everyone here. So maybe a bad example. I have asked this in the past, and maybe the way I asked it was different, because I know that I have had people say yes, they would change. They just don't like the inequality. It's important that it's there's no reason for the inequality. It's just random, arbitrary, unfairness. You get 10, everyone else gets 20. And okay, so the answer, everyone said no. All right, that was my fault. Bad example. I wanted an example maybe where some people said yes and some people said no. I think if I asked it differently, I could get that. If I made it sound like, what if the people who chose 20 did it, they knew you were going to get 10 and went along with it. In other words, they could have made it be equal, but they didn't. They chose to make it so that they all had 20 and you only got 10. I don't know. Then it becomes like an ultimatum game, I suppose. So let me just say what I would have said as if at least one person had said, yes, I would change. So maybe somebody would say yes. The goal of a rational choice model is to quantify this dissatisfaction you feel with the unequal payoffs, and then to include this into the utility function. Most of us, our utility, good one, Ibrahim. When you get the second offer, your rational mind starts to say, okay, yeah, I'm a little annoyed at getting less than everyone, but still, I should. $10 is better than 8. This is what he's saying, and I get that. There is some element of like which part of your brain. Daniel Kahneman has a great book. It's called Thinking Fast and Slow. There could be different parts of your brain that react differently to this conundrum. The thinking fast part of your brain would say, "This sucks. I can't believe they're getting more money than me. No way. I'm going to go with $8. Everyone gets 8." Whereas that's the thinking fast part of you. The thinking slow is a little more deliberative in considering ultimately, what are you going to do with this money? You're going to either have $8 in your wallet to spend, or you could have $10 in your wallet to spend. And you start thinking about which of these options is better and whether or not you really care about other people getting 20. And that sort of more deliberative process may actually cause you to choose the $10 and let everyone else have 20. But I didn't mean for this to be a lecture about that. That's kind of an interesting point that Ibrahim brought up. I don't get the last word of your comment, James. Daniel Kahneman. I don't know what that last word is.
I don't know.
President Kahneman.
Oh, Kahneman. Okay, got it. Yes, Nobel laureate Daniel Kahneman. Yes. Okay. So why? Oh, by the way, let's get back to this these slides. When I say why, I mean, why is it that we want a utility function to include this dissatisfaction? The reason is so that the rational choice model would predict that some of you would choose the $8 option instead of the $10 and $20 option, because it maximizes your utility to do so. In other words, it's worth $2. Yes, you do lose $2 by choosing the $8 instead of the 10. But at least if you choose 8 instead of 10, you avoid the dissatisfaction that you get from the inequality. So do you guys see the point? The point is to take something very psychological and raw, which is the dissatisfaction that you experience from the inequality, and quantify it so that it can be entered into your utility function, so that we can have a model that would predict that you will do the thing which maximizes your utility. And the thing that maximizes your utility is to lose $2 and go to 8 instead, but avoid the dissatisfaction of inequality, which would give you a higher utility than if you accepted the inequality. You'd get $10, but you would be annoyed how everyone else got more than you. And you'd feel it was unfair, it would leave a bad taste in your mouth. I think I know a little bit about what this experiment was worded in a way that you alone have the power to like make everyone's payoff go down, and you might feel a little guilty about that. I think that was a problem in the way that it was worded. Like if it could just happen on its own without you causing it, maybe you would rather live in the world where everyone just got 8. It's not you have no responsibility for it. It just happens to be where everyone gets the same amount. You all walk out with $8, and that might make you feel better than if this other world where everyone gets paid 20, but you only get 10, and you know it, and it leaves you salty the rest of the day. Okay. Do you guys have any questions about the point of a rational choice model of social preferences? The point is to change your utility function in such a way that would predict that some of you would choose the $8 option, and some of you wouldn't. So that's where the parameter comes in. There has to be some sort of parameter that says, if you're like Brody, you'll take the $10. So what? Other people are getting 20 instead of 10? You don't care about that. You'd rather have the $10. And if you're like Kevin, is Kevin here, by the way? Maybe he's not here. Dang it. If he were, I would be curious to see which one of these he would choose. No, I don't think he's here. Wait, he's here. Are you not listening, Kevin? Dang it. I want to know if you would take the 8. Oh, so if you could, which would you prefer? The outcome where everyone gets $8 or the outcome where you get 10 and everyone else gets 20? Let's say you don't cause it. There's no responsibility for having caused this outcome. You're just saying, which would you prefer? We may be getting at.
I'm still reading over this at the moment. Sorry, I was like taking care of like a few other things. But as far as when it comes down to an outcome where, you know, like if everybody puts in a certain amount of work and then some people tend to get more than others, I just don't agree with that.
Yeah, well, so it's not really work. It's some work. You're just volunteering for some experiment.
Okay. It's a volunteer. I mean, let me see what this is. You get paid 10, everybody else gets paid 20, and everybody puts in the same amount. Yeah, I guess I'd be pretty upset about that, yeah.
You'd rather just everyone get the same amount of $8?
Sure, yeah.
Okay.
If I felt like if I put in the same amount of work and everybody else did too, why should they get more than me?
Exactly. Okay. So we have at least one person, and I chose you because I was kind of hoping you would say that. Where they would prefer the outcome where everyone just gets $8. And most of you, everyone else that responded in the chat, said actually you would rather have the case where you get 10, even though other people are getting 20. We want a model of social preferences that says, let's take all of this into consideration. Let's take into consideration how much money you get and how much everyone else gets. Let's take into consideration where you fall on the Kevin Brody spectrum. If you're towards Kevin, you're going to want the $8 because at least that's equal. If you're towards Brody, you're going to not care if it's unequal, and you're going to say, well, I'd rather have the 10 because 10 is better than 8. That's the goal. And then it goes even further than this, because let's say we analyze your behavior in a question like this, and then we take that knowledge and project how we think you would behave in a different situation. If we can do that, that's a very successful model. Those are called out of sample predictions. If I gather some gather some data based on how you behave in this particular thing, and then I say, well, how would those same people behave in this other situation? If the model is good, it says I've learned something about the way you make decisions that I could use in a new situation. And the Fair-Schmidt model actually is not perfect in this regard, but it's okay, right? The truth is there is no perfect model of social preferences. There's many I could have taught you, but I'm just going to go with this one because it's the most heavily cited. And in academia, we care so much about citations. You know, whose work is the most cited?
Argument. So I'm sorry to cut you off. I just felt like mentioning this. My main argument for like the whole, I mean, some people call it socialism. I don't even see it that way. I just see that like people putting like, we're all putting in a relatively equal efforts. Or I understand that like people have certain specializations, and I think that's important to consider. And if there's a way that we can take out the incentive or keep the incentive of, you know, wanting to like pursue business and like pursue career, being able to really get as much as you can out of the workforce, if we can have that while considering, I believe that we're all equal, that we're all like really spiritually connected. So if one person within a conglomerate is perceived as making more than another, I think that there are psychological ramifications to that. And sooner or later, the people that feel oppressed, by the like the employer employee kind of. I mean, I don't know, man. I'm
Yeah,
not saying
it's
I mean, a
not
whole lot
that
of
deep.
but-
You're going a lot deeper than you need to about politics and economics.
Oh, maybe so, maybe so.
So,
But
I'm not saying none of that matters. Of course it matters. In the real world, it really matters. It might determine who you support for president, for example. But in an economics class like this, I'm just trying to do the very, very first step, which is to say, how does what we know from remember that big table of games? I gave you that chart with those 8 games that I told you about are in it. There were 2 in each column, 4 columns times 2 games each. How can behavioral economics sort of tie all that together into an explanation that satisfies the scientific method of here's a theory, gather some data to test it, and if it's true, we've learned something about human behavior. That's all we want, is that very first step. And to think about how it applies to the economic systems of capitalism versus socialism versus communism, that's all way, way down the line. We're not going to even try to sell. That's above my pay grade. I'm just a economics professor at VCU. I'm not going to say anything about whether you should support capitalism or regulated capitalism or socialism. I mean, it's an interesting study, just not really for this class. This model is about how do we feel about this distribution of payoffs. That's it. If there are unequal payoffs, it makes us feel a certain way. If there's equal payoffs, it makes us feel a different way. And we quantify that into a number so that we could put it into our utility function, and out from the utility function comes a prediction that says, you will choose the thing that maximizes your utility. If I can make you understand that, then I think I've done my job. Of course, I have to give you the specifics of this model. But I almost think it's more important for you to understand how modeling works in general, rather than focus on this particular model. If Fair and Schmidt are watching, I like your model, I'm teaching it to my students, but I really don't think it's the most important thing in the world, sorry. I think the idea of how to model is more important. How to think of a rational choice model as applying to real human behavior is more important. Okay.
Professor,
Sure.
would you mind if I interject here?
I would love it.
I'm looking at this theory that we're testing, and the issue that I see with the 10 and 20 and then changing it so everybody has $8 is twofold. First, it's unfair to everyone to reduce their payoff from 20 to 8, but it's also a disadvantage as a selfish individual that you also have the reduction of $2 to the $8. When you are modeling and you're setting those parameters, is that something that you can account for in setting restrictions?
Yeah. So to summarize your point is, you said it, you used the word unfair to talk about reducing the payoff from 20 to 8 of other people. Didn't you say that?
Yes.
That is the problem with the way I've presented this, because you're thinking of them. They start out with 20 and you're taking away 12 of their dollars because you're a jerk. That was the wrong way. I apologize. I had to present this to you. My first presentation of this had to be something, and I chose this. Maybe it wasn't the best way to do it, because this model is not about that act of taking money away from other people. It's really just about which distribution do I prefer. Do I feel better about the distribution where there's 4 people, they 20, 20, 20, and 10 for me, or the distribution where 8, 8, 8, 8, right? I get 8, everyone gets 8, or the distribution where I get 20, I get 10 and 3 other people get 20. And it's not even about necessarily would I impose my will on others. Would I say, I'm going to take $12 away from you because I just feel like, like a crybaby who can't handle it. I've been watching Cobra Kai, and the idea is like, don't be I can't even say those words. It's like, don't be a crybaby. Just accept whatever it is. Somebody else get more than you. I don't know. That's not the best example, but I don't think what your criticism of the model necessarily applies here, because what you're calling unfair is a relative thing, comparison, saying starting at 20 and taking away 12 is unfair. Whereas actually, if your notion of fairness is just how even, how spread out, how equal are the payoffs, you're going to say the 8 is more fair than the 10, 20, 20, 20, because you're getting less than them for no reason. It's not that you're a worse worker. It was just I think that's unfair that you happen to get less than them. So don't think that this example is how we're always going to use this model, because it's not. It doesn't make sense to like start out with 20 and then you're choosing to take away 12. That's too much psychology that I didn't intend to be in here.
I have a question.
Maybe it'll go. You have a comment?
Yeah. If this experiment were framed in the other direction, do you think that the outcomes that you see would be different? If you start where everybody has 8 and you have the option to change it to where you get $2 more and everyone else gets 12 more, would we expect different outcomes?
Yeah, maybe. I actually think people would be okay with letting others have 20 if it just happened randomly, you know? The unfairness is sort of bizarre in this experiment, as opposed to the ultimatum game, where that sort of represents an exploitation. If somebody's playing the ultimatum game and they say, I'm going to keep $9 and only give you 1, not only is it unfair, it's unfair in an exploitative way. Somebody say, well, I'm the first mover, so I get to keep $9 and you only get 1 and you should just accept it. I actually think that's maybe the better way to think about this. The unpleasantness of having been treated unfairly should go into your utility function. Whereas in this experiment, I know why I chose this example, because I didn't want to talk about any sort of reaction, sort of like a penalty. I didn't want to think of it as a reciprocity. I just wanted you to focus on what are the payoffs. But it's unavoidable. We all, as human beings, we all start thinking about, what's my responsibility for having chosen this over this? And I didn't want it to be about that. Let's just go on. I think I need to talk to you about the model, and then some of this will make more sense. That's okay. Wait, I'm trying to go to the next one. Here we go. So let's talk about the model. By Ernst Fair and Klaus Schmidt, it's called inequity aversion. Interestingly, they didn't call it that in their first paper. They wrote about this and it's published in 1999. They called it a model of equity, reciprocity, competition, something like that. But it's commonly known as inequity aversion. Inequity means something which is unfair. It's not the same as inequality. You guys know the difference between equity and equality? Equity is more like, it's about fairness. Like everyone had the same chance, but something happened that it was just unfair. Not necessarily that it was unequal, but it was unfair. So inequity aversion means I don't like it. I'd rather avoid the inequity of a situation. That's what this means. I think it's most popular. Certainly if you go by citations, it's the most popular. Okay, so here's the gist of it. Your own payoff exists in your utility function in what I would call a normal linear way. In other words, your utility function is linear in your own payoff. If you get $4, it gives you a payoff of 4. It's linear with a coefficient of 1. So it's just literally your own payoff is the most important thing in this model of inequity aversion. But you also suffer some disutility. That just means it lowers utility. Something gives you utility, it increases it. If something gives you disutility, that means it decreases your utility from the unequal payoffs. And let me be more specific about that. So how does the inequity happen? If your payoff is smaller than another person who's playing the same game, kind of in the same boat as you, I don't know why I said they. They is the person I'm modeling. their payoff, smaller than another person they're playing this game, they get a disutility of alpha times the amount they are behind that person. This is called disadvantageous inequity. I'm reading out loud what I wrote, and I'm not even sure that's the best way to make sense of it. I hope it makes sense to you, but let me just rephrase it. And that is, if I'm getting $10 and other people are getting 20, like in the example, I suffer a disutility, which is the difference between 10 and 20. 20 minus 10 is 10. So I suffer according to that difference of 10 times this parameter. And the parameter is called alpha. It's always called alpha. In this model, it's alpha means what fraction, or what's the extent to which that inequity bothers you. So if alpha equals 0, that means that inequity, by inequity, I mean the fact that other people are getting 20 and you're getting 10. Through no fault of your own, they're getting a lot more money than you. If you have alpha equals 0, that means you don't care at all about this fact. It just goes right off your shoulders. You're like, so what, they're getting 20? I don't care. At least I'm getting 10 bucks. 10 bucks is pretty good. It's the Brody end of the spectrum. And that's called alpha. What if alpha is big? What if alpha is equal to 1? If alpha is equal to 1, that means this difference of how much more are other people getting than me. If alpha equals 1, that means I care about that just as much as I care about my own payoff. That's what alpha equals 1 represents. In other words, if I'm getting $10 and everyone else is getting $10 more, my own payoff is 10, great. But I suffer a disutility of 10 and it cancels each other out. I would actually rather not get anything. I'd rather just not even come to the medical experiment at all if alpha equals 1. Because the fact that other people are getting twice as much as me causes an inequity of 10 times my alpha of 1. That's just as strong as the okay, so I'm giving you numbers here. I'm going to have to give you some better examples, some numerical examples, and I will. But I just want you to first now think of alpha as being this parameter where if it's 0, that means you're totally self-interested. I don't care if other people get more than me. And as alpha grows, the more I care about this fact that other people are getting more. If alpha is 0.1, that means I care a little bit. It doesn't really bother me. It bothers me a little bit, but I'm okay with it. If alpha is 0.2, starting to bother me more. 0.3, 0.4, alpha equals 0.5, it starts to be a real thing. I'm getting pretty annoyed by the fact that they're getting more than me. Alpha is 0.6, 0.7, and one I would say is pretty high. You know what I will say though? The maximum alpha that people have seen regularly is about 4. People can go all the way up to alpha equals 4. That's how much like extreme they could be in hating inequity. In other words, it's more important to them than their own payoff. If alpha is greater than 1, that means you've flipped to the other side now, where you care so much about inequity, you'll give up a lot of your payoff to enforce it. In fact, if alpha is greater than 1, $1 of inequity is worse to you than $1 of your own payoff is good. Okay, so with this model of inequity aversion by Fair-Schmidt, we can say everybody out there, every single person who ever existed, has some alpha, and the alpha is restricted. It cannot be negative. Emily, we talked about this before class. Emily was very clever, and she said, I gave you a reading assignment where I asked you to say what happens if, or why alpha should be greater than 0, but nowhere in the model does it say alpha should be greater than 0. Actually, it is implied by the model because of the transitive property of inequalities. So I'll get to that in a second. But the model assumes or implies that alpha has to be positive. Alpha can't be negative. What would it mean for alpha to be negative? If alpha is negative, that means inequity is good, especially disadvantaged inequity. I like it when you have more than me. I like to just personally be the type of person who, I like to be a martyr. Martyrdom just makes me happy. Fair and Schmidt say that can't happen. We can't have people like that because they restrict the parameter alpha to be greater than 0, okay? Or equal to, sorry, greater than or equal to 0. So all I've told you so far is that in this model, there's something called alpha, which measures the extent to which you care about disadvantageous inequity, the type of inequity that helps other people and hurts you. And that alpha could be anywhere between 0 and 4. Really, technically, there's no limit, but it's at least greater than or equal to 0. Okay, let's talk about beta. Beta is the other side of the coin. Beta is the amount of disutility you get. Beta is beta times the amount you are in an advantage. For this case, you'd have to think of the case where you get 20 and everyone else gets 10. What if this were an experiment where they single you out and say, all right, we've decided you're going to earn $20. Everybody else, they only earn $10, but you get 20. You may actually experience some guilt for this. Because there's unfairness, which is helping you. You are benefiting from this position, and that's called advantageous inequity. And beta is a parameter that says how much you care about that. Let's talk about what it would mean if beta equals 0. If beta equals 0, that means you don't care at all about this being treated well. You know, like, let's say you're a kid at Christmas and all your brothers and sisters get like socks, but you get like a brand new bicycle, right? Everyone else gets socks. Your big brother gets socks. Your little sister gets socks. You get a brand new bicycle for no reason other than they felt like giving you one. You probably be happy, like, yay, I got a bike. But you might also feel a little bit of guilt that you got such a better present than everybody else. Sorry, I'm being very, I don't know why I'm choosing the Christian religion and their holiday. It could be any holiday where there's gift giving. But this is what beta measures. Beta measures like this sort of awkwardness and feeling guilty, like, oh crap, well, yeah, thanks. I guess I'll take my great present when everyone else didn't get one. It makes you feel uncomfortable. And once again, a rational choice model quantifies that discomfort and sticks it into the utility function for the purposes of making predictions. In other words, you will choose the thing that gives you the highest utility. Okay. Here's another thing. The same player can get both types of utility. You have a parameter alpha that says how much you care about disadvantage inequity. You have a parameter beta that says how much you care about advantageous inequity. You can have positive alpha, positive beta. You could be in a situation where you're being treated better than someone, but worse than someone else. And you sort of feel the inequity relative to both players. Mathematically, let me say how this works. According to the model, what you do is you add up the disutility of comparing yourself to every player, and then you divide by the total number of players. What do I mean by the number of players? I mean the number of people that you're considering as equals in this game. You're thinking of inequity in the sense where I should be treated fairly, just like everybody else. how many people are in the everybody else? It could be there's only one other person, in which case you divide by 1 and that doesn't do anything. But if there's 3 other people, you actually think about what's my inequity relative to this person, second person, and the third person. I think about that inequity, I add them all up, and I divide by 3. Why do you divide by 3? It's because what you really care about is your inequity per person. If you're in a market with 10,000 other people and they're all getting something great and you're getting something worse, it doesn't really make sense for you to feel personally aggrieved with every other person in this market who's getting a better deal than you. It's more about, on average, how do you care? How do you compare yourself to the average person? You don't compare yourself to every single person and then add up that disutility, that discomfort. At least that's what the model predicts. Okay, I'm asking you guys to do a reading assignment by Wednesday. So what I actually want to do is help you with that. I want to reward you for being here in class and paying attention. And one of the things I ask you in this reading assignment is the parameters, the restrictions on the parameters. So let me talk about those now. Hopefully this will help you answer. If you've already submitted your reading response, I will grade it and I'll try to be lenient because you're not going to benefit from what I'm going to say right now. But if you haven't submitted your reading response, you should pay attention because I'm going to help you make sense of these restrictions. Okay, what I have on the screen now is the mathematical representation of inequity aversion as presented in the paper, the reading that I ask you to do, the reading response. The paper I ask you to read is the original paper, the very first paper on inequity aversion by Fair and Schmidt. I'll have you read, not the whole thing, just like the first 2 sections, approximately. See the assignment. But in that paper, this is how it's represented. Let me just say a little bit about it. I have a little bit of time. Ui of x, can you see my cursor? Ui of x means the utility of player I, like you name all the players. I'm player 1, player 2, player 3, player 4. I just means it could be any one of those. Whatever the player's index is I. Whereas this x here represents a payoff distribution. So x represents not just my payoff, but everyone's payoff. So the utility of player I, given this distribution x, is equal to, the very first term is xi. What is xi? Well, if you can think of x as a vector of payoffs, xi means that's player I's payoff. It's their own payoff. The very first thing in this mathematical model expression is my own payoff. That's what I care about in a very linear way. So if I get paid $4, I get 4 units of utility from that $4. If I get paid $8, I get 8 units of utility from my payoff. That's what xi is. Okay, next term. It looks complicated, but I just want to say a few things. I want to say that this expression here, the maximum of xj minus xi comma 0, this will only exist if somebody's getting more than you. Think about it. You are player I, and if there's some other player, let's call that other player J, if player J's payoff is higher than your payoff, then this will be positive and it will exist. If player J is getting less than you, that means xj minus xi will be negative and it will just disappear because this whole thing, this will turn to 0. So you may not be familiar with sigma notation either, but this means add up for all players J who are not equal to I, how much more are they getting? That's all this is saying. So let's say there's 4 people in this psychology experiment where they're all getting 20 and you're getting 10. That means there's 3 other players, each of them are getting 10 more than you. So this just says add up the amount that other players are getting that's more than you. So it'd be 10 plus 10 plus 10. This number would be 30. But remember, we're multiplying it by two things. Alpha, that's the extent to which you care about disadvantageous inequity. You're also multiplying it by 1 over n minus 1, which is 1 over the number of other players. If there's n players, that includes you. So if there's 4 players, n minus 1 is how many other players there are. So there's 1/3. In this example, it would be 1/3 times 30 times alpha, which is kind of what I said before. It's 10, other people are getting 10 more than you on average, and you care about that according to alpha. You multiply that by alpha. Sorry, I know that's complicated, but I'm asking you to read this to try to make sense of it. Also, you should watch my video. I have a video about inequity aversion, and it'll help. Okay, how about beta? The same thing is true for beta. You should think of this as just adding up all of the cases where now, look, xi minus xj. These are the cases where I'm getting a higher payoff than other people. It's like Christmas where you get the bike and your siblings all get socks. You feel a little awkward and guilty about that. This whole expression is describing beta times the number, divided by the number of other players times the total amount you're getting that's more than the others. Okay, this is really just a long way of saying my utility is equal to my own payoff minus the disutility I get from envy, from other people getting more than me, minus the disutility I get from guilt, from getting more than other people. Now let's talk about the restrictions, because that's what I asked you about in the reading response. It says here that beta I should be less than or equal to alpha. What does that mean? It means it's saying something about the strength of our emotions, that the emotion of envy is stronger than the emotion of guilt. I think that's pretty true. Although you can argue in your reading response whether you agree. You might think that for some people, maybe because of their background, they've grown up to think they should never be given more than they deserve, and that guilt is really strong for certain people, and that should be included in the model. But Fair and Schmidt decided, let's not have that in the model. Let's just assume everyone that their alpha is at least as big as their beta. So their envy is at least as strong as their guilt. That's it. They decided to put that in so that when you're fitting the model, you're trying to estimate the value of alpha and you're trying to estimate the value of beta, you'll have this restriction built in. Okay, so you can write about that. And here's the other one. Beta has to be between 0 and 1. Okay. Did I have you write about both? I forget which one. But let me just talk about this and what this would imply. Beta is how guilty you feel. If it were less than 0, it would mean you actually enjoy this fact that you got more than others. You would sort of revel in your siblings not getting the bike that you got. You have this Schadenfreude. Maybe some people actually have that. Maybe some people, we should have allowed beta to be negative. Beta to be negative is like this prideful, just rub it in your face that I got more than you. If you think that a lot of people actually are like that, you should say that in your reading response, and I will read it, the Bezos factor. Haha. You think Bezos loves the fact that he's richer than the rest of us? He might.
100%. 100%.
Okay, he probably does. So he may have a negative beta in that case. But Fair and Schmidt decided to restrict beta to say it has to be greater than or equal to 0. And here's the final one. And basically, we can be done after I explain this. Beta should be less than 1 because, according to the model, because if your beta is greater than 1, that means you dislike getting a bonus. You dislike having an advantage so much that you would rather throw it away. You'd rather nobody get it. That if your beta is greater than 1, this is like saying when you're brothers get socks for Christmas. Here I am using the Christian holiday, apologize. And you get a bike, you would rather just the bike disappears. Just throw the bike in the garbage. That's how strongly you would have to feel about this guilt if beta were greater than 1. So if you have some time, tell me in your reading response if you think that makes sense. If you think it makes sense that nobody has a beta greater than 1, because nobody would feel so badly about giving something that advantages them that they would rather just disappear, because that's what it means if beta is greater than 1. Okay? So for next class, hopefully you guys will check out this paper by Fair and Schmidt on Blackboard. Send me your reading response, usual time, and then we'll do more. We'll do more actual problems using the model. I've told you about the model, but I haven't had you use it yet. We will do that next class. Maybe we'll use breakout rooms, but if you guys hate breakout rooms, I just won't use breakout rooms. But that's it. You guys have any questions? You would just share the bike. Good point, Kevin. Nobody, maybe what Kevin is saying is that nobody feels so badly about receiving a gift that they would rather the gift just be destroyed rather than having received it in the first place. You thought of a good solution, which is sharing the bike, but imagine a case where you can't share it. That's what this paper is about. Then get rid of it. Whoa, Kevin, your beta is greater than 1? That's weird. Maybe Kevin is the example of somebody with beta. Yeah, you can't share. In this particular example, you're getting a high payoff. Other people are getting low payoff. And you have the option to lower your payoff so that it's the same as everybody else's. Or you could just enjoy the good thing that you have. You'll feel a little guilty about it, but you'll still enjoy the thing. So this question of whether beta can be greater than 1 or whether it can't be greater than 1, you should say beta can be greater than 1 if you think that there are people who feel so guilty about receiving a gift that they would rather just throw it away instead of receiving it. Or you should say beta can't be greater than 1 if you think there's nobody out there who would feel that guilty. At least not enough people to influence the model. Okay? Hopefully this helps a little with your reading response. People are doing pretty well with the reading responses anyway. I don't think you need my help, but since you're here listening, I decided to give you some help. Guys have any other questions about the class going forward? We should stop.